moving along. A bakery sells 10 different kinds of cake. How many different sets of 3 cakes can be purchased if they must be of different kinds? Well, again, order is not important. It's just a straight counting problem where order doesn't matter, so it's a combination. You want to choose 3 cakes out of the 10 possible kinds, and that is 10 factorial over 3 factorial times 10 minus 3 is 7 factorial. And again, if you plug that into the calculator, you've had plenty of practice now, you'll find that there are 120 different ways that you can choose 3 cakes out of 10. Next, notice that there's not a lot of new concepts. We're simply practicing these things over and over again. I am going to make a point here, though, in this problem that I want you to pay close attention to. It says if 4 letters are randomly drawn from this set of 8 letters, A, B, C, D, E, F, G, H, what is the probability of getting A, B, C, D in that order if the letters are drawn A with replacement? In other words, we draw a letter, we look at it, then we put it back in before we draw another one. Now that means that we can use a letter more than once. This is basically a product rule, going back to the rules that I showed you at the very beginning. This is basically a product rule or probability problem. In other words, I'm just multiplying a bunch of probabilities together to get the final answer. I'm going to draw one letter. What's the probability of getting, I want it to be an A. Well, there are 8 letters and I want to draw an A, so the probability of drawing an A is 1/8. And then I want to draw a B. Well, what's the probability of drawing a B? Well, if I'm putting the letters back, there are still 8 letters, and the probability of getting B is there's 1 B out of 8, so it's also 1/8. You can kind of see where this is going. Now I want to draw a C. Well, there's only 1 C in there. I put the letters back, so there's still 8 letters, so the probability that I get a C is 1/8. And last but not least, I want to draw a D. Again, I put all the letters back. There's only 1 D in there, so I've got a 1/8 chance of getting a D. So the product rule of probability says the probability of drawing A, B, C, and D in that order is the probability of drawing A, and then B, and then C, and then D, and you multiply them together. And if you do that, you end up with 1/8 to the 4th. 1/8 raised to the 4th power, or 1/8 to the 4th. Well, I can do a better job of that. 1/8 to the 4th. And 1/8 to the 4th, if you take 8 to the 4th power, you're going to get 4,096. Again, you might want to leave the answer like that. If you do want to change it to a decimal, just plug it into your calculator and you'll find out that that's approximately 0.000244. In other words, that's a very small probability of happening. But I want to change that a little bit. Instead of saying I'm doing it with replacement, let's say that I'm doing it without replacement. The problem doesn't change really in setup. You still want to draw an A, followed by a B, followed by a C, followed by a D. But the big difference with having replacement versus not replacement is that you don't put the letter back. So when I'm trying to draw an A in the beginning, there's 1 A out of 8. But if I don't put the A back, the probability of drawing B, well, there's still just 1 B in there, but I didn't put the A back, so there are only 7 letters left. And then when you move to a C, again, there's only 1 C in there, but I didn't put the A and B back, so there are only 6 letters to choose from. And when I get to D, again, there's only one D, but by now there are only 5 letters to choose from. So if I'm doing it without replacement, I have to make that adjustment. So I end up with 1 divided by 8 times 7 times 6 times 5. If you do that on the calculator, you'll find out that that comes out to be 1680. And as before, if you did want to change it to a fraction, it would be easy enough, and it would come out to be, I think I'll put it down here, 0.000595. Again, a very small probability. But you should be getting better at this. As you practice more and more, you get better at this kind of thing.